Starter is all done, and now it's time to move on. And we need to do a little example with decomposition. It's a new reaction type. And so I'm going to tell you a little bit here first about decomposition. That if you remember, synthesis was putting things together. So that was A plus B is just AB. Now what we're going to do is reverse that. So decomposition is just taking AB, breaking it apart into A plus B. Okay? So let's do one, because we did magnesium oxide synthesis, okay, and it looked like Mg plus O2 becomes MgO, magnesium oxide. So we're going to reverse that. So this time let's take magnesium oxide, and we're going to break it up. Well, what does it break into? Two pieces. Magnesium plus O. So notice I first, same process, I wrote the reactant. We only have one this time, MgO, magnesium oxide. When it breaks down, it makes two things. So I wrote the products, Mg and O. Step 3, I've got to do diatomics. The first diatomic with magnesium oxide on the left, the oxygen is already traveling with a friend, so no reason for a 2. On the other side though, that oxygen is traveling by itself, so it does need a 2 behind it. Magnesium, not diatomic, so we're just going to leave that one alone. Balance the molecule on the left side. Magnesium's plus 2, O is minus 2, and so Mg and O, that's perfectly balanced right the way it is. All right. Got to always work with balanced equations. Well, we have 2 oxygens on the right, so we've got to put a 2 here. That means we need a 2 there and a 1. All right, so we're all set now ready to do the stoichiometry. Notice from the starter there's a little bit of a difference here in that we've got to do that cross multiply and divide twice because we have 2 products. So we'll get to that. Let's draw some lines first, get ourselves set up, do the artwork. Remember, these are grams down here, and this one is the atomic mass. We get that from the periodic table. This is what we are given, okay? And across the top here is moles, always moles on top, because our recipe, our equation is in moles. All right, this time given magnesium oxide, I'm going to start you off with 120 grams. All right, let's go figure up some atomic masses. Magnesium and oxygen. Remember, there's just one of each. So magnesium, if I look it up in the periodic table, is 24 grams. Oxygen is 16. Put the 2 of those together is 40. Notice I did not do 2 oxygens there because there's only 1 in magnesium oxide, MgO. All right, the next one, Mg. I only have 1 of them, and so that is 24. We do not use those mole coefficients up front. Notice I did not use this. Don't do that. That would not be good. All right, the next one, O2. So O2 is 2 oxygens. So it is an oxygen plus an oxygen, which is 16 plus 16 is 32. So make sure that you got both of them in there. All right, let's do a little division here. Notice on this side, this time, convert mass to mole, we've only got one thing to do. So 120 divided by 40 is going to be 3. Okay? All right, so since we only have one reactant, we already know what's limiting. It's our single reactant. That one right there is limiting. So for X and Y, we have 2 things to find. So the first one will be, use that one, so 3 over 2 equals X over 2, because that is that one, okay? And I'm going to switch to green over here for a minute because of that. And I'll switch some colors here too, I think, so you can see. So I'm going to use the same one from there, 3 over 2, because that was my limiting one, is equal to now y over 1. So I have 2 of these problems to solve. So if you go ahead on through and figure up the first one, 3 over 2 equals x over 2, well, that one's going to be 3. And 3 over 2 equals y over 1, that one is going to be 1.5. So we are just about done. We just have a little bit of multiplication to do. So we're going to do some multiplying here, right there, 3 times 24. 3 times 24. And if you get out your calculator, 3 times 24 is 72. The other one, 1.5, okay, times 32. 1.5 times 32. 1.5, do it on my calculator, times 32 is going to be 48. Notice that when we add those two, 72 plus 48, we get what we started with. That's a good check so that you know you did it right. That's really true for decomposition reactions because you only have one reactant and you're breaking 100% of it down. That's when the reaction stops, and the 2 pieces have to add up to the total that you started with. 72 plus 48 is 120. So that's the example on decomposition, and we'll be back in just a moment, Fred and I will, to talk about your seesaw activity for today.